All right, guys. Very good evening, everyone, and let me start recording as well. So you guys have had a couple of days of a couple of sessions. So you guys have had a couple of interesting sessions on different aspects of data engineering. And today I want to keep it open. It's your day. So it's your day today. Ask me any question related to data engineering, and I will try and answer to the best of my knowledge. And I also have certain things that I have planned for the session, but I want to keep it as open as possible. I want to keep it as interactive as possible. You guys have already seen, what are the different things which are required in data engineering in the couple of sessions that you had. The first session you had was using SQL, as a data engineer, and we used FIFA data set, and we saw some aspects of how SQL can be used in the data engineering world. And then yesterday you had an interesting session with Abhishek, with Ashish, and you learned various different aspects of data engineering. So let's start with any questions that you guys may have. I mean, you can use the chat window or you can ask verbally. I'll keep a note of any of the question that you're asking, and then we'll try and answer those questions as quickly as possible. So go ahead, guys. I mean, any questions? It's your day. It's your time. Any questions related to data engineering career? You can ask me any profile-oriented question that, I'm X skilled, and, how do I go into data engineering, or what are the different aspects, or any topic that you have not understood, or any concept that you want to understand about data engineering. I'll be more than happy to talk about it. So ask me anything. Anything, guys. So all right, let me then understand from some of you. So Bhagyashri, any question? Deepika, any questions? No? All right, no worries then. What we will do is we will look into what are the different aspects about data engineering, and then you can probably think of asking any of the questions that may come to your mind. So remember, in data engineering, as you must have seen in the last couple of sessions that you had, data engineering is part of the entire data pipeline that we talk of, and the data pipeline is divided into five stages, grouped into three phases. Data engineering is the first phase, and then analytics, machine learning, and the delivery, right? So if I look at these phases here, then you would notice that these three phases they pertain to data engineers or data engineering, and these two things are specific to data science. So what does a data engineer do? So data engineer is supposed to be the provider, as we say, that data engineer is the provider of the data infrastructure, right, which the data science team consumes. So this is the provider of data, and this is the consumer of the data. Okay, so imagine you are building, or you're constructing a building, and then there are people who are living in that building. So let's say as a data engineer, you build a hospital, right? And as a doctor, you use the facility of that hospital. So that's the same analogy that you can use here, that a data engineer builds the entire data technology infrastructure and is responsible for ensuring that the data is available for the data science team to use in order to make decisions. So that, in brief, is the entire data pipeline, and that's where data engineer fit into, right? Now, just like a good doctor can't really, I mean, in today's time and age and world, a good doctor can't really function effectively unless he or she gets all the instruments, the right infrastructure, the right technology to use, right? Similarly, a data science person or a data scientist can't work effectively unless the data is available and the technology is available, the data technology is available to the data science person. So that is the reason why, as long as there is data, there will be at least two roles. One would be the engineering role, which would provide the infrastructure, and second would be the consumer role, which is the data science role, in order to use and utilize the data to make decisions, right? So that's typically what you would see as a, I mean, the relation between data engineer and a data scientist. Data engineers are mainly tasked with transforming the data into format that can be easily analyzed and consumed by the data science people. They do this by developing, maintaining, and testing the infrastructure for data generation. We'll see some of those examples again. And they work closely with the data science team because the data science team can't do their job without the data engineer. So this is not my definition. This is the definition by Glassstone. Now, data engineers generally, in terms of the background that they come with, the background that they come with is typically, one of the engineering background is what we have noticed: computer engineering, information technology, applied maths. So we've seen these kind of backgrounds generally, but I've also seen in my experience, there are people who have done MSc in economics or even MBA general. They have transformed their career into data engineering as well. However, they have to, of course, work harder than a typical computer science engineer or an IT engineer would have to do, or an MC or a BCA person or a BSc in IT kind of a person would have to do. And the reason for that is that as a data engineer, you work very closely with the technology tools. Maybe you're not coding every day, but you're using a lot of technologies together, right? Because you are assembling a lot of tools together so that the data can travel from the source all the way to reporting tools and machine learning tools like Python and Power BI and Tableau and whatnot for the data science team to use. So that is the reason why technology, being a technology driven person, being a tech savvy person, is one of the important skill sets that you'll have to exhibit as a data engineer. One of the other questions that people ask me is that, practically, specifically, what do data engineers do? You might have gotten some glimpses in the last two sessions. However, I will still tell you, as a data engineer, you're responsible for collecting, ingesting, and preparing the data, and as well as the corresponding infrastructure. And I'm going to show this visually to you so that we all can actually relate to this. Now, let me ask, what is the most popular app that you use in your phone? Or maybe let me narrow it down a little bit. What is the most popular food app that you use while you're ordering food? Anybody? What is the most popular application that we use on the phone to order food? I would probably say Zomato or Uber Eats or Swiggy, right? One of these tools, one of these apps, right? For example, imagine you order from Zomato more frequently. Now, how data engineering come into the world of Zomato order system, right? And this use case is something that everybody should know if you want to get into the world of data. And it's not difficult. So let's say normally we use Zomato app on our smartphone, so which is our mobile app, which is a mobile application. Or at times we can also go to Zomato website and we can order there as well, right? Or imagine at Amazon Pay is running a special food festival on Amazon, and they say that order directly from within Amazon platform by using Amazon Pay from Swiggy or from Zomato. So that means through Amazon Pay or through Amazon app, you're now placing an order which is going to be into Swiggy, into Zomato ordering system. And that happens through something called as a microservice, right? So that happens through something called as microservice. So through a bunch of service, which are small services through which the Amazon app is now connected to Zomato infrastructure, and it is sending the data using microservice to Zomato platform. So, or imagine, we all have refrigerator at home. Now, modern refrigerators, I'm shopping for a new fridge for my house, and I saw that there was a lot of refrigerators in the store which had screen on them, and they were all connected to Wi-Fi. That means those Wi-Fi connected refrigerators can be then called as internet-enabled device or Internet of Things or IoT-enabled device, which we popularly call it as IoT device, Internet Internet of Things device, which are essentially devices or appliances that are connected to the internet. So here, now imagine if Zomato has a refrigerator app. Won't it be very convenient to just, you realize that, all right, I don't want to make today one extra veggie. So I want to just order that one food dish from Zomato app by just clicking on the refrigerator app. So now there, the order is now coming from Zomato app, from their web portal, from a third-party microservice enabled app, or an IoT app, right? That means an app on an IoT device. So the data is collecting. So as a data engineer, you want to make sure that all this data, all these are ultimately order data only, all this data come to Zomato infrastructure or Zomato database. It should, all of them should hit without any security issues, without any mess up in the data, should come into Zomato database, and that would happen. So that is called as ingestion, to ensure that the data from different sources all come in a secure, in a clean, or in an error-free fashion to Zomato data repository, which can be called as a data lake. Now, why not data? Why am I not calling it a database, and why am I calling it as data lake? Because data lake is a collection of structured as well as unstructured data repositories. Structured databases, which we normally call as DBMS or RDBM, relational databases, for example, Oracle or SQL Server or MySQL or PostgreSQL. These are all structured databases. For example, when we place an order, so that is just the predefined set of data that gets stored in the database. So that is structured. But what if you give a feedback over a chat, or maybe a a picture of something? So that would be called as the unstructured data. So data lake contains the repository which are structured as well as unstructured data. So when the data is in the data lake, right? So that means the data is ingested. So first the data was collected, then ingested into the data lake. Now, as a data engineer, you're also ensuring that all these things are talking to each other very well. And in the data lake, from the data lake, now, so remember, you ultimately want to make sure that the data is available to the data science team. So how would the data science team get that data? So from this data lake, right, through, if the data, through a lot of different tools, it can go into the final data warehouse, and from that data warehouse, the data science team can pick it up. So if you notice here, I mentioned Spark, and I've mentioned here stream runners. So what happens is, let's say every minute, let's say there are 100 orders that are coming on Zomato. So every hour, maybe there are 6,000 orders coming to Zomato. Now what happens is, here in Zomato kind of infrastructure, the order data that has come, right? And let's say there is a data science team, which is, or marketing analytics team, which is part of data science, which is sitting right over here and needs access to the data in order to maybe give a special promotion to set of users in a particular city. So they would need access to that data. So maybe they're okay to get access to the data, which was, maybe an hour older data. So entire 6,000 orders that might have been placed on Zomato app in 1 hour can then be batched processed. Batched process meaning, in the entire batch of 6,000 orders would then go into a data warehouse as a summarized data. So, data warehouse meaning where we will store the data in a summarized fashion. Summaries of the data, meaning what kind of orders were placed, how many total orders were placed, which city, and what number of orders, and which restaurant, what number of orders. So these all summarized data could then be hosted, can be stored in a data warehouse, because as a data science person, you need access to this data, summarized data, very, very frequently in order to make decisions. And here is where the data science team come over here, which is presentation. So this is when they will pull the data out from the data warehouse and make decisions or make presentation reports and dashboards and whatnot. So that's how the entire data pipeline works. These three things, all the way till here especially, are part of data engineers, right? Computation and presentation computation, machine learning models, running them, and so on and so forth, is part of a data science person, right? So as you can see, as a data engineer, you don't work with one tool, you don't work with just a couple of tools, you work with plethora of tools. So it's like a complete assembly line. So as a data engineer, you one of the things that I always say that I've seen observed, that a person needs to be a little tech savvy, should love technology. So that's one of the very important things to understand about being a data engineer. One of the very common question that I keep getting asked is, should I how should I decide whether data science or data engineering track is better suited to me, to my profile? See, both the career options have significant opportunities. Okay, and both, as long as there is data, there will be demand for both, plus minus a little bit here and there. Right now, one can say yes, there are a lot of demand for data engineers, because we are going through a very growth phase because of the pandemic. You know, a lot of data got, a lot of digitization happened, and a lot of data got created, and a lot of people have started using variety of applications on their phone. So there is, a burst of data that has happened, and hence you require more data engineers to make sure that infrastructure is ready. So yes, there is more demand right now in current time that we're living in, but the demand would be probably, let's say, 5-7% more. But there is still enough and more opportunities in the data science and in the data engineering field. So how do we decide? So on the basis of two things that we decide. One, I always recommend that if you love technology, love for technology. That's a bare minimum thing, because if you do not love technology, then data engineering can be a very tough field to get into. Second thing is, if you're not a person who likes to be involved in business decision making, or if you are a person who would be more happy if people don't come to you and ask you business question, but come to you and ask you technology questions, right? So I say that problem solving skills related to technology. I'm sure you must have had friends who you call up to ask, hey, my Wi-Fi is not working, my router is not working, or my computer is not working, what should I do? So those people we call in traditional way that, okay, they're tech savvy people, because they will have answer to technology. Here, as a data engineer, the entire data team would depend upon you to answer technology oriented questions in the data pipeline. For example, my SQL query is running very slow, or when I fetch the data into my Power BI dashboard, it is taking extremely long time. I feel I complete my cup of coffee and still it is pulling the data. What can we do to optimize it? So they will ask you questions like this. Or maybe if you're working in a company like Hotstar, which says, hey, you know what, India Pakistan match is coming next month, and there would be more than 1.5 crore or 15 million people who might end up watching the match. So how do we scale the infrastructure so that there is no buffering? FIFA started up last week, and we saw that Geo Cinema, which is the official streaming partner in India for FIFA World Cup 2022, they got a bad mouth from the users because there was a lot of buffering happened, because they did not scale, they did not forecast probably they could not forecast the kind of users that would be there. So then they had to scale it up. So all these kind of questions, which are data technology questions, if you picture yourself, if you portray yourself solving these challenges more than solving business questions related to their businesses, for example, how much money will I make, or how much cost saving will I get? Those are the questions which are answered by data science team, but any data technology oriented questions are answered by the data engineers. So that's something that I say that, that is the first and the foremost thing that you must ask yourself. Do you love technology? Would you be interested to answer such questions more than the question that a business person would ask about their business? So that is the first and foremost thing that I always say. This is the first set of things that I always recommend people. if somebody has to ask me, okay, what else, in terms of what tools or what skills are required, what are the skills required to become a data engineer? Any thought, guys? What are the skills which are required to become a data engineer? Any thought, anybody? Any thought? Any thought? What are the skills which are required? All right, so I'll show you one slide which will tell you the 7 steps to become a data engineer, which also includes the specific skills one must have as a data engineer. All right, so let me pull that slide up for you. Step-by-step roadmap to build data engineering skills. So there are these 7 steps, which also includes the core skills that one must learn and one must be ready to exhibit as a data engineer. One is coding fundamentals. Now here, we are not going to design a lot of algorithm-driven codes, which will, let's say, make a rocket fly faster. But we will be using a lot of these tools like Python and Spark, and basically we call it as a functional programming, where we depend upon a lot of libraries and a lot of integration tools which are already available on these tools, these programming platform like Python and Spark, to create that entire assembly line of data pipeline, right? So you're not building a lot of algorithms. So your data structure algorithms concept like DSA concepts, yes, you should have fundamental knowledge of it, but you don't have to be like a kick-ass DSA solver to get into data engineering kind of coding that we need here. But you can't say that you hate coding or you hate programming, because in data, as a data engineer, you are expected to work with programs, you're expected to write codes, but your codes are not going to be like millions of lines of code what an app developer would write. Your codes would be more like, okay, I've got data residing in a microservice, I want to create an API, like a window, to bring the data from Amazon website through API call, bring it into my internal Zomato data lake. So there is a integration API function which is already available on Python and Spark, and you should be able to at least build that. I mean, so essentially things which are pre-created, but you should be able to write the logic behind that. That okay, when will we bring the data from this API call to our data lake? So that kind of coding you will have to do. There is no doubt about it. Okay. Now, the second thing is learn to automate. Now, why this is important? You see, a good data engineer would identify that what are the repetitive tasks that we do every day with data. Say, for example, you every day at 6 p.m. in the evening, you're supposed to download the data from 3 different sources, right? And then you're supposed to clean the data. Maybe there are duplicate customer information, there are duplicate order information, you want to clean them up, or maybe the date column of the order date is not matching with the targeted database that we have. So you have to write that algorithm. So you have to do that cleaning every day. So as a good data engineer, what you would do is that you would end up automating these tasks. At every day at 6 p.m, run this script, bring the data from 3 different sources, and then process them as a batch, send it to the data lake, right? So you would actually end up creating an automated program, which is not very difficult. There is something called shell scripting, which is which is Linux based, generally Unix based, but again, it's actually easier than the kind of code that we do over here. And most of these shell scripting codes are predefined. We do not end up creating a lot of them again and again. So if you know the fundamentals, you can easily find plethora of predefined codes which you can use to automate your daily task. Okay, this is a very important thing, because this brings efficiency into the entire data pipeline, right? Your data science team will thank you for automating some of their tasks. Your team, internal team, and you yourself will feel that, okay, you know what, I've been able to save a lot of time. So automation through shell scripting, batch processing is something which is very, very important. You don't want to be waking up at 2 in the night every night and do the same mundane task. If you're able to, create a shell script for that batch processing, that like every 2 a.m. In the morning, you do these 3 tasks, you automate that thing, and then your life becomes much easier. You see, at a fresher level, what I have seen most of the companies focusing on 2 things. One is basic Python understanding. Second is database and SQL. Now, SQL becomes your bread and butter. And the reason is that whenever you are moving the data from one source to another, say, for example, here we spoke about moving the data from a mobile app or microservice or web app or IoT. All this data movement that normally happens through SQL, structured query language, as we saw in the SQL session that you must have had with me. So SQL is the bread and butter tool for a data engineer. Without SQL, anybody who says that you can become a data engineer would be wrong. You would be grilled on SQL. You're supposed to know SQL more than just an intermediate level. You should know how to pull the data. You should know how to model the data. How to model the data, meaning, what does it mean? Let's say, for example, you have one table which has customer information, also has order information in the same table. Now, since you have 2 different categories of information stored in the same table, so there will be redundancy, there will be duplicates. So what you will end up doing is that you will end up dividing them into fact and dimension table, as you may say. So let's say, or you end up dividing them into multiple tables. For example, customer table will be one table. Normalization, yes, Shravani, absolutely right. Normalization is something that you got to know, and you have to be very good in normalization, asset properties. All these are very, very important concepts for a data engineer to know. And customer, and then you'll have another table for orders. And then you will end up creating a relationship between them, right, through primary key for. So any such modeling, I mean, this modeling concept is something very, very important for a data engineer to know, and you will be grilled in the interview around these concepts as well, okay, which we call as schema designing or entity relationship designing. These are very important concepts from a database perspective. And then you, as I said before, you have to become proficient in SQL, because without SQL you can't talk to the data sources, right?
Sir,
Yeah.
Sir, I'm sorry for interrupting, sir.
Sure.
Sir, the thing is that if the data is unstructured in nature, we won't be able to use SQL in that case, right?
Then you use no SQL with it.
No SQL with it. Okay, fine. So thank you.
And you see, what is no SQL? So if your data is like a text file, your data is a video file, an image, then what happens is that SQL, which basically you can use on structured data, and hence it is called a structured query language, you can't use on unstructured data, text, video, and images. So then comes NoSQL. NoSQL and the database which supports NoSQL famously is called as MongoDB. It's one of the very famous open source database which support NoSQL. But NoSQL is not just SQL. So it still requires concepts of SQL. Without knowing SQL, it becomes very difficult to work with NoSQL. And NoSQL, frankly speaking, doesn't have so many complications as SQL. Because in NoSQL, the idea is very simple, that you got these flat files that you work with, and you end up dividing them, distributing them into different places, and then you end up summarizing, what kind of files are stored, what is stored in that, and so forth. So yes, if you understand SQL, and if you understand databases, for you to pick up an unstructured database like MongoDB and understand NoSQL is not going to be very, very difficult. So yes, SQL is must, especially as a fresher. That's your basic assumption, that you know SQL very, very well. And not just SQL or no SQL, if you know, very good as a fresher, but as even at the 1 or 2 years of experience level jobs, if you want to crack, then you should also have a very good, decent understanding of NoSQL. But it is actually not very difficult to learn NoSQL. But yeah, I mean, the idea is that what I have seen in most of the job openings, okay, and let me see if I've got a job opening from one of the companies that just recently reached out to us, and we are co-designing a curriculum with them, whereby we will deliver the curriculum. But give me a moment if I can find it. That would be great. So the company is math company. They reached out. So what we're trying to work with them is we're trying to create. We actually have already done it, but we are trying to create a curriculum with them, whereby, yeah, this is the one. Let me open it. Not open. So look at the job description that they have given to us. So our curriculum is now aligned to their curriculum completely, because they have a lot of openings. So if you notice, this is the job opening for an associate 0 to 2 years. So build and maintain the data pipeline to support large scale data management. Experience designing robust ETL tools. ETL is extract, transform, load. So whenever we transform the data, I mean, bring the data from different places into a data lake, or whenever we take the data from data lake to a data warehouse. So, you do ETL or extract, transform, load kind of things, something that we saw in our SQL session. So look at SQL. Okay, SQL becomes an extremely important thing, right in the top thing, right? Scalable data pipelines and analytical deal. Experience in big data ecosystem, either on premises or on cloud. But so in our course as well, I mean, what we do is that first we train you on premise technologies, because a lot of these things can be hosted on your own machine, and then we expose you as to how these can be hosted on cloud, so which is a very, very important thing as well. So yeah, worked on query languages, again SQL, and tools such as Hadoop, Pig, SQL, Hive. So you can see, and Hive, if you know SQL pretty well, then learning Hive is not a big deal at all. Spark SQL again would require your SQL understanding prior. So yeah, so these becomes SQL becomes extremely important. Is a base for a lot of learning a lot of other things. Okay, so from a perspective of skill, SQL is a very, very critical skill, and you have to be very good in one of the databases. I think somewhere they have mentioned also that you should be very good in one of the databases, and you can be good in other databases, that's fine, but good understanding of relational dimensional modeling and ETL concepts is what they mentioned in the preferred qualification, as you can see. So you have to become very good in one of the databases, and you should have worked with a couple of flavors of database management softwares. For example, if I were to say, let's say you are very good in MySQL database, then but you should also have had some exposure with SQL Server, and maybe an Oracle database or PostgreSQL SQL database. So one expertise and a few other flavors, and should know how they differ from each other. So yeah, I mean, our course now is completely aligned to what these kind of companies ask, because they're the consumer of the people who we end up training. So yeah, so that is about SQL and database. Now you should become expert in processing data. Processing data basically means that I mean, I told you that there is I had shown you the figure here, right? Processing, batch processing. I mean, imagine you're working with a bank. There are so many millions of transactions happening every day. So what happens is that you do not end up sending each data about each of the transaction that is happening on real time to the data warehouse, but you send them in batches. Let's say every 15 minutes you form a batch of all the transactions that happened, and then you send them into a data warehouse, so that the data science team can start using. So batch processing is something which is very, very important, and Spark becomes very, very important platform to know batch processing. It supports a lot of other things on top of it, so it's a very, very important thing. If it is not batch processing, and if it is streaming data, say for example real-time data, that the moment the transaction happened, the data warehouse should get updated. So if it is streaming data, or maybe it's something like you're streaming some movies like Netflix or Prime or Hotstar, right? So if there is streaming, if there is a lot of streaming data that is happening, so you should know how to set up the streaming entire pipeline, and Kafka is a very, very important tool, Apache Kafka, to use to set up the streaming thing. So as you see, right, I mean, there is Python, shell scripting, SQL, Spark, Kafka, right? I mean, they all have to work together as an assembly line. And as a data engineer, you are making sure that all these tools work together, right? So you are an assembler of all these things so that the entire data pipeline is working together. And then learn ETL workflow. ETL workflow, as I said, right? I mean, how's the data flowing from the source, let's say, to the destination, which is in this case is data warehouse? How is that entire flow happening, right? And you want to make sure that there are no quality problems that are happening. And Airflow happens to be one of the very important tool to kind of set that up, how the data is flowing in the entire workflow. And learn modern day virtualization, not visualization here, but virtualization. You see, what happens is, in today's time, what has happened is that when we, let's say, you want to install a database management software. Now, in the earlier days, what would happen is that you would actually install it on a cloud machine, or you would install it locally on your machine. Now, when you're installing on any computer machine, a database management software, let's say MySQL, you will be worried about installing all the related component, because MySQL is it's a database management system. It requires tools to set it up, server. It requires a lot of drivers. It requires a lot of things, right? So a lot of times, when you are installing such heavy software in your local machine or in the cloud machine, some of the other thing may or may not work properly. And if you're trying to install this kind of a large complicated software across thousands of users, so it can be a very complicated task. So what we end up doing these days is that there is a concept of containerization, or creating container of the software, meaning they're like small virtual environment, right? Virtual environment meaning, just to kind of show you in a diagram view, let's say we have our computer machine, let's say a laptop. So it has Windows OS, Win OS, right? This is my computer main OS, right? On top of this, they will create one layer, a Docker layer, which will host a container. Container is, for example, there is a container for MySQL, right? Now, this container includes all the things that are required for MySQL database management software to work. It is all packaged as one container, which is hosted on something called as a Docker engine, which is sharing the resource, or which is installed on the Windows OS, right? And sharing the resource of your computer. So what happens is, when, let's say, person A, right? Let's say person A has installed one Docker, which contains, it has installed, let's say, MySQL and then it has also installed other containers. So let's say container 1 contains MySQL, container 2 contains some other software on a Docker engine. Now, what they can do is, they can just send this to person B, right? And they can say that, okay, you just take this container, host it in your own Docker. You don't have to do anything else. Just pull this from my container to your container in the Docker. You would not even have to set it up, no installation, nothing is required. Just transfer and switch it on, and the Docker engine will switch it on. So it becomes, what happens is that it becomes very, very interesting way of hosting and launching your application. Just to give you an example, I've got this Docker desktop app, and if you are interested, I'll in the YouTube channel, I'll put a link whereby you can actually see how you can actually install a Docker app, Docker desktop in your machine, and how you can actually install a software like MySQL on your machine. So it does take a little bit of time to switch on, but it is switching on. As you can see, this whale symbol is for the Docker. Now, if you notice, it is a containers, and it is still starting, and you will see that there is a container that I've already created for MySQL here. So it is starting, but it does take a little bit of time to start. The reason why it takes a little bit of time, because again, on this Docker engine, we can install and we can host many software applications, right? So it takes a little bit of time to switch on first. Now, if you notice here, it says that, okay, this is a Docker here, and I just have to do very simple thing, which is just click on play, and that's it. And then this Docker will get started, and it is started. And now it is started, and then I can go to my MySQL workbench, if you remember from my session from MySQL, and I can connect to this Docker very easily. So I can actually just click on this Docker MySQL predefined connection, and it is now established a connection with that Docker engine. Now, what is very interesting to observe here is that, let's say if I have to share it with you, and if I already have a Docker here, I can just pull it. I can just share it with you, or you can pull it up from the Docker website as well. This instance of pre-packaged instance of MySQL, which is already there. You just have to pull it into your Docker desktop, and that's it. No other installation required, no other package, no other driver. You're not concerned about whether Visual Studio is installed on your machine or not, and all of it. Nothing at all. So what has happened is, with this, virtualization has become very, very easy, right? And as a data engineer, since we work with so many different tools, right? We work with so many different tools here. So if you end up creating packaged virtual environment, which are hosted on your operating system through this Dockerization, as we call, then, you know, a lot of headache about installation, about rectifying installation errors, and all of that goes away from a data engineer's work, right? So that is why this has also kind of become an important thing to know, and it's not difficult to know. It's actually not difficult to know. First time it looks like, oh, it's a new concept, but it's very interesting, and it's very, if you follow the steps, it's not difficult to know. Before I go to step number 6, I will just tell you, among all the steps, from 1 to 6, I'm reminding you, focus on fundamentals, because the interviews always start from fundamentals. You know, a lot of people end up focusing towards the later part of the things. Don't focus on only the fancy buzzwords. I know I've spoken about workflow, virtualization through Dockers and processing the data. But if your fundamentals are not clear, the interviewer will not even continue with your interview. But if your fundamentals are strong, for example, your SQL is installed, your basic data pipeline concepts, or your Python is installed, your shell scripting is installed, is strong, then what happens is, or your Spark is strong. If these concepts, some of these fundamental concepts are strong, then the interviewer knows that, okay, given an opportunity, you will learn, right? Never ever the interviewer would ever start from the most difficult concepts or most advanced thing. They will always start from foundation, fundamentals, because that's where they test. Have you fundamentally, foundationally understood the concept of data engineering, and are you strong on those concepts? So please always take my advice, focus on fundamentals. Learn SQL very well, learn Python very well, learn batch processing using using Spark. Spend some time, learn shell scripting. If you have learned these things, then you have won, believe me, at least from an interview perspective, you have won at least more than 2/3 of the battle. Okay, even more than that. Most of the time, I've seen people faltering in these foundation concepts. Okay, so please focus on these foundation concepts, guys. Now, once assuming that you've done all of this, then make sure that you make your skills social. In Ivy, you know, one of the things that we always do, you would find that LinkedIn is filled with our students talking about what they have learned, what they have worked on as a project. Everybody is talking about that, and that's something that we encourage in our students, and we then end up help them create something what is a social resume. Now, just to give you an example of a social resume, you'd be surprised, you know, how young people get benefited extensively by doing these small things. So instead of putting your favorite pictures on Instagram, we always say that you learn a new skill, you apply, and you talk about that skill on LinkedIn and on your Instagram if you want. Just to give an example of one of the social resumes that we end up creating, or help people end up creating in Ivy Pro. So you'll see that, you know, if you look at this resume, right on page 1, there are projects and there are links given for each project. And if you go to her profile, she has cross-referenced these links of the projects on her LinkedIn, and she has she's built a story around her project. And then what happens is, hundreds of people would end up talking about it. And if you're good at it, then go ahead and, you know, participate in online competitions as well. Give reference. It's not about winning, but it's also about participating. Now, if you want to take one step further, then go ahead and talk about these things. Go ahead and create small tutorial, write a blog, create a video tutorial on and host it on YouTube. Now, at IvyProSchool, we give this facility and we host student videos, student created tutorials on a channel. That gives student a lot of confidence when they see thousands of people are viewing the channel, liking, talking about them, commenting. It becomes an extremely interesting thing. So do this also, guys. This is very, very important. So that's a very, very important thing that I always say, that if you are not making your skills known to the world, that means if you're not marketing your skills and your projects and your concepts that you've learned and applied, then you are hiding behind a shell. And a recruiter will not know who you are, what you know, unless you are in front of them. And LinkedIn is the best platform. Okay, if you want to become even more famous, you can consider YouTube, you can consider Instagram as well, but LinkedIn is the most important thing. So these are the steps that I strongly recommend, guys. Believe me, if you follow these steps, we have transformed so many careers. If you follow these steps, you would be able to get benefited, guys. So that is what I wanted to talk about, guys. We got around 8 to 10 minutes. Feel free to ask me any questions. Feel free to ask me any questions, guys. So yeah, I mean, in our program, the cloud data engineering course at IvyProSchool, I'll give you the link also. You can just Google also and you'll find us. What you would notice is that we do provide placement assurance here in this program, of course, subject to certain conditions. However, what you do, I mean, what you get is you get to learn from the same folks who are actually, people who have done all this data engineering, pipeline creation, and so on and so forth, all their life, I mean, all their young life, and with companies like some of the biggest companies like Microsoft, Amazon, Google kind of companies as well, or Accenture, and so on and so forth. And also, you learn the same pedigree. See, IvyProSchool is official learning partner with companies like Genpact, Honeywell, Tesco, Accenture, and Coca-Cola and whatnot. So you get to learn the same content with us. You get to work on the projects which are given by these companies as well as part of the interview process. And as I just told you, right, I mean, we just don't work with them, but we actually work and create content along with them, right? A lot of our modules are also delivered by our industry partners, so that you get that industry exposure, true industry exposure. So do check it out, and we prepare you for some international certification. You can choose to do either Google or you can choose to do AWS. AWS happens to be famous, and Azure is also becoming quite famous. Cloud tools are very, very important for us. So yeah, I mean, you do get industry endorsed certificate, and also this is a NASSCOM certified program, so you get rebate, and you get Government of India certification as well. You get rebate of up to 12,000 rupees, if I remember it correctly, from the Government of India directly as well, if you of course fulfill all the certification requirements. Any questions, guys?
Hello.
Yeah,
good evening, sir. Sir, actually, I want to know that which cloud technology is good, means it is AWS or Azure, means
which cloud technology is better to learn?
Yes.
Yeah, it's one of the other
Yes.
questions that I commonly get asked, that okay, which technology tool should I focus on? Cloud technology. So which cloud technology is better? Which cloud platform is right? Now here are the three one, right? AWS, then we got Azure, then we got Google Cloud Platform, right? Is famously called as GCP. Now, see, the answer is not very straightforward, Sobe. So I always say, so from a market perspective, from a market share perspective, if you ask me, this controls around 35% of the market share. This control around 15% of the market share. This control around 11%, and the rest is divided among smaller players. Now, what happens is that what I have observed that, or what I recommend to my learners is that focus on at least one cloud platform and become very, very good at it. Then picking up the other cloud platform will not be very, very difficult. Remember, if you look at the entire data engineering skill stack, right, you are learning a lot of things, SQL, Python, big data technologies like Hadoop and whatnot, data warehousing, Apache Hive, Scala, Spark for streaming, Kafka for streaming, and Spark for batch processing. And then comes the cloud. Do you understand, Sovik, what I'm trying to say? Now, cloud is an important thing, but there are a lot of things that you do outside of cloud, and then same thing you replicate on cloud. So if you are good in rest of the things, assuming you're good in the rest of the things, then after that you adopt one of the cloud platform, be it Azure. For example, the current batch that we're doing currently is on Azure because the demand that we have gotten from one of our clients is for Azure resources. So what happens is that adopt one cloud platform if you become very good at it, and if you are able to install all these tools that we spoke about, which are not cloud specific, which are open source. Most of the other tools that we have spoken about, Kafka, Spark, Scala, all these are open source tools. So they can be installed on any cloud platform. So if you become very good in one of the cloud platforms, one of the top 3 cloud platforms, you can easily become, you can rather easily pick up the other cloud platform with not much of trouble solving. So the answer is not very straightforward because I have seen opportunities for all different kind of cloud platforms. What happens is, as an interviewer, I mean, when I am also interviewing, I would rather first focus on the other tools because there are quite a few of them. And then I would say that, all right, one of the cloud platform that you've worked with, which one is that? So if the answer is AWS, I say, all right, but we got projects for Azure. Would you mind learning a little bit about Azure? So it'll actually take you not more than 15-20 hours to understand how these data engineering tools can be installed on Azure. And then after that, you learn as you go. Is it making sense, Sovi?
Okay. Yes, sir.
Thank you, Zibran. So yeah, I mean, as you can see in our program, our program is completely aligned with what is asked what is asked as a JD in a company. For example, these are the things which are asked in the math company data engineer associate profile, and we cover all of them. And we cover all of them with specific project scenarios, right? I mean, the idea here is that we help you build the entire data pipeline from scratch. We help you face those challenges that a data engineer would face, and we help you solve those challenges. So one project we make you do with us, and this one project has multiple parts component to it because it's the entire data pipeline, and then one project you do by yourself. So that's something that we focus on our program. All right, guys. So that's what I had as a content for today's workshop. Do check out the cloud engineering page that I shared. IvyProSchool's cloud engineering program is gaining a lot of momentum. And also, if you're not subscribed already yet, do subscribe to IvyProSchool's YouTube channel, guys. You'll get not just today's tutorial backup or the recording, also you will get all the other 2 sessions, and you will get a lot of other industry speakers that were spoken about, people who company founders who are hiring in the data space. They have spoken about it. So there is a nice analytics Shala series also that we run, where we bring people from all around the world to talk about what is going on in the industry, what are they looking for. It's a great thing. You can also learn from our past students' interview experiences from different companies. So do check out IvyProSchool's YouTube platform as well, and it'll be great if you subscribe to it. Thank you, guys. And if you want to be connected with me, just Google Prateek Ivy, and the first link that you will get on LinkedIn would be mine, and I'll be more than happy to be connected with you all to answer any question related to the data world. That's what I like to do. And so this is my LinkedIn ID, and I'm also giving you my email address in the chat window, prateek@ivyproschool.com, and I'll be more than happy to be connected with you. All right, guys.
Sir, hello.
Go ahead.
Yeah, sir, actually one question is there that Jira technology means which is used in industries means Jira.
Jira is agile technology to manage the project, scrums. Yeah, go ahead.
Yes. So this is important for us to know.
Yeah, I mean, see, as a data engineer, DevOps is an important thing, and you learn about DevOps as part of the program, which is how do we manage a data engineer or data engineering related project or data infrastructure related project. So,
okay.
But yeah, I mean, those things are not very difficult to learn, Sovik, because they're intuitively designed to be easier because they're process oriented. Do you understand, Sovik, what I'm trying to say? It's not very, very difficult to understand those things. More difficult things are these that you can actually easily pick up in in a day's time if required. And then you learn once you start working, you'll be given an orientation as well. If it is a Jira specific, if it is a company which is using Agile to manage their product, then you will be using Jira or one of the such similar tool. If they're using DevOps for managing the data infrastructure project, then we'll be using DevOps. So it's not difficult. These are process-oriented things. These are not difficult for a tech-savvy person to understand.
Okay.
And believe me, since you asked this question, so feel free to Google a little bit about it. You will realize that it is actually not difficult. Yeah, one more question somebody had.
Is data structure required in data engineering, sir?
Data structure algorithms, you said, Ismail?
Yeah, yes.
See, I mean, okay. Yes, in any coding, you're supposed to have understanding of data structure algorithms, but not to an extent a full stack developer would require, Ismail. Okay. Fundamentals of data structure algorithms are important for anybody who's working with any programming tool. Okay, any programming language. So to answer your question, not to an extent a full stack developer would require, but yeah, foundation of data structure algorithm should be good, because without that you'll find yourself struggling while creating small programs that we normally do using Python or even using Scala. But it's not difficult to learn, Smile. When it becomes complex is that when you are optimizing, or when you're creating a very, very complicated algorithm to build a software completely. So that's
not just like using SDE profile, because in SDE profile, the major concept algorithm data structure algorithm. Right. So in data engineering, that type of algorithm needed. Yeah.
No, not at all. No, not at all. But again, as I said, repeating myself, foundation of data structure algorithms are important to excel, in any kind of coding tool. And they're not difficult to learn, Ismail, the level that is required here. So some pseudo coding, you should know, all the control structures which are there, what happens, which control structure to use in which situation. So those kind of things are definitely important to understand here. But yeah, not to the level of, a full stack software developer engineer would require, to know in terms of data structure algorithms. All right, guys, great. You all have attended all the 3 sessions of the data engineering bootcamp series that we had this week. So feel free to boast about it on your LinkedIn profile. Talk about the fact that you learned it. Once you get the certificate, do speak about it. Do summarize your learning of the 3 sessions. Put it on your LinkedIn profile. You can tag me. You can tag your trainer. You can tag IvyProSchool. Remember, IvyProSchool has more than 10,000 followers. So automatically, your post can then be viewed by so many thousands of people if you actually tag us on your on your LinkedIn post. Yeah, so that could be a great thing for you. So do remember this, that if you do not market yourself, nobody else will. So do market yourself, guys. It's very, very important. Yeah, thank you, guys. If I learn, so Nagaraju's question is, if I learn all these software communication skills are mandatory. Well, as a data engineer, I mean, communication skills are important for anybody, but as a data engineer, not really presenting that much, Nagaraju. A company would rather first focus on your data engineering skills. But yeah, I mean, if you do not have basic communication skills, how will you articulate what you know in front of the interviewer? So that basic communication skills are important, but not to the level that a data scientist or a data visualizer or a data presenter would require, Nagaraju. But yeah, I mean, communication skills is something that if you have little above average communication skills, it always helps to excel better in your professional journey in general, Nagaraj. Thank you, Mayur. Thank you for your feedback, Mayur. He says he learned quite a bit in the bootcamp series. Thank you. Do not, again, as I said, I'm repeating myself, do not forget to talk about these learnings on your LinkedIn profile. You can tag IvyProSchool and you can tag me as well. you'd be surprised how much visibility it gets to your profile when you talk about your potential recruiters are all there on LinkedIn, guys. Yeah. Alrighty, guys. If you like this session, do give us a review on Google. It'll be great if you can do that. I'll share a link with you all. Do please. Yeah, do give us a. Give me one moment. Do leave a quick review, guys. That'd be great. That'd be very, very helpful, guys. If you can leave us a good review, and it helps. That's the only publicity that we do, and it will be helpful. Thank you, guys. Thank you for attending. Have a good night, and feel free to reach out to me on LinkedIn and otherwise. Thank you, everybody. Bye bye. Have a good one.